So let's have a practice of using both formulae, and you'll be able to see, I think, that the second one is usually a lot easier. A weighted die is rolled, so that means all of the outcomes 1, 2, 3, 4, and 5 and 6 are possible, but it looks like the weight has made it a lot less likely that it's going to land on a 2 or a 5, so perhaps those are opposite each other and it won't land on either of those ends. It's more likely to land on one of these other sides. They've listed the probability of each outcome. Now, all the probabilities should add up to 1. That's a good little check to make sure that our question makes sense. And sometimes we have to find a missing value there, which is quite straightforward. Now, we're going to use the first formula, and the first formula for variance says find the expected value of x minus mu squared. Now, that means that in actual practice, we need to find x minus mu all squared and multiply by the probabilities and then add them up. So the first thing we're going to need is mu, and mu is what we find in this box here when we add up all the scores multiplied by their probabilities. So multiplying each of these numbers together is the first step. 0.5, 1.2. That was quite easy to do in my head. Now I'm going to add these up. That's 1, 1.8 plus 1.2, that's 3, so I've got 3.5. So my expected value here, or mu, is 3.5. Now I'm going to be able to use that no matter which formula I use. So I'll put that over here and circle it, or perhaps you'll circle it on your working because you'll need it later. Now I need to subtract mu from every score. So think how far apart 1 is from 3.5, 2.5. You then have to square that, because whether you do 3.5 minus 1 and get 2.5, or 1 minus 3.5 and get negative 2.5, either way when you square it, it's going to be positive. So 2.5 squared is 6.25. Now, how far apart are 2 and 3.5? 1.5, and when you square that, you get 2.25. 3 and 3.5 are half apart, and when you square a half of a half is a quarter. Now this one is actually, this example is not too bad to do with the first formula. I can actually do a lot of these in my head, but a lot of the time you get nasty numbers here that are not easy to work with at all, or you might get a nasty number here that's going to really make it difficult. 4 is half away as well, so it's going to give me the exact same answer. 5 is 1.5 away, so it's going to be the same as this one. And 6 is 2.5 away, so that's going to be the same as this one. Now here, luckily I had a bit of symmetry, so I have 3.5's bang in the middle, and that helped me find some missing values pretty easily. Now I don't really need to add these up yet. That sum column is sort of there. This is the useful part. The first formula is going to give me the variance once I get that. So now I need to multiply these numbers by the probabilities. This is where I'm needing to reach for my calculator, and I'm feeling like it's maybe not the best method, because 0.2 times 6.25, I can do it in my head, but it's not easy, and so it's going to take me a little bit of time now. Okay, so I've taken a moment and I've filled in that row. I've basically multiplied each of these numbers by those numbers to get these numbers, and then I've added them up, and now I've got my variance 3.05. Using my first formula, finished and done. Let's compare that now to how we would work it out with the second formula. Now the second formula has a different last two rows, and in fact it really probably only needs one row, because I think we can do two things at once here. We need x squared multiplied by, that p doesn't look very good, does it? The probability of x. Now some people will do a row of x squareds, and then underneath that a row of x squared px, but I can square these numbers in my head really easily. So I think it's easy to do two things at once. 1 squared is 1, and I multiply that 1 by 0.2. 2 squared is 4, and 4 times 0.1 is easy to do. 3 squared is 9, 9 times 0.2 I can do in my head. 4 squared is 16, 16 times 0.2 is 3.2. 5 squared is 25, and 25 times 0.1 is 2.5. And 6 squared is 36, and 36 times 0.2 is going to be 7.2. Again, here I'm just using rules of thumb such as 36 twos is 72, so 36.2s is 7.2. Now again, to play it safe, you might want to work all of those out on your calculator, but I figure at least there's only one row of things to do here, not two. Or you could say one set of things to do that are very easy in your head and one thing to do in the calculator. Now I need to add these up, so I've got 0.6, 2.4, 2.6, 5.6, 6.1, 8.1, 15.3. Now that's not the variance. We're not finished yet because the second formula, which we're using now, I need to adjust this, says find the expected value of x squared and then subtract mu squared. So to find the expected value of something, you add up that thing multiplied by the probability of it, and now we need to take that off. So what we've found is we've done x squared px for everything. We've added them all up. That's this part. So we've got our 15.3. Now we just need to subtract 3.5 squared, and I'll reach for my calculator from that bit, and my calculator gives me that same answer I got with the first formula of 3.05. Now in this example, the first formula and the second were not too different, but as soon as mu is a bit of a nasty looking number, something that's not going to have anything simple and there's a lot of calculator work to do, I would use the second formula every time. Now, you can do everything the same up to this line because you need mu for either formula anyway. So once I get to here, if this is a fairly round number, I take my pick with the formulas, but if it's a nasty number, I go formula 2. Now the only real downside to formula 2 is that you need to remember how to apply it. When you get to here, you might feel all self-satisfied, like you've done so much work and this should just be the answer to the variance. But in fact, that's part of your formula. You still need to subtract mu squared. So that's an area you could make a mistake and mess up. The other thing to note is that if you want the standard deviation, and that's just sigma itself, not sigma squared, then you need to find the variance first and then take the square root of that, and that will give you the standard deviation.